This is a help video for reviewing for the Conservation of Energy exam, Part 2. This is the second help video for preparing and reviewing for Conservation of Energy exam. This video will cover Lesson 4, Calculating Kinetic Energy and Potential Energy. Here are the key points for Lesson 4, Calculating Kinetic Energy and Calculating Potential Energy. Pause the video and read through the key points of Lesson 4. We will move forward and cover the key ideas with slides that contain images and figures. How do we calculate kinetic energy and potential energy? Ke is the symbol for kinetic energy. Kinetic energy is measured in the unit joules, just like all other forms of energy are measured in the unit joules. Joules is abbreviated capital J. Joules is the metric unit. Energy is measured in. M is the symbol for mass. Mass is measured in the unit kilograms or grams in the metric system. You find M in the equation for calculating kinetic energy and in the equation for calculating potential energy. V is the symbol for velocity or speed. Velocity is measured in the units meters per second. V to the second power, that's superscript 2, tells you to square the velocity. That means to multiply velocity by itself. V times V equals V squared. So it's important to note that velocity or speed must be squared before multiplying times mass. After you square the velocity, multiply times mass. When you get that number, then multiply times 1/2 or divide by 2 to get the value for kinetic energy. PE is the symbol for potential energy. PE with a little g, subscript g, is the symbol for gravitational potential energy. Sometimes you see that little g there, and sometimes it's dropped. Gravitational potential energy is measured in the unit joules. Joules is the metric unit. Energy is measured in. M, we've already stated, is the mass. G is the acceleration due to gravity, and it's a constant. That means it's the same number every single time you calculate potential energy. You will plug in for G, 9.8 meters per second squared. That number you will plug in for all of our problems for calculating potential energy. H is the symbol for height. And height is measured in the unit meters. These are the two equations for calculating the quantity of kinetic energy and potential energy. Let's do a practice problem and see how we do. Here we have a 5-kilogram ball is pushed across the floor with a velocity of 5 meters per second. What is the kinetic energy of the ball? So the ball is moving rapidly across the floor, and the ball has a mass of 5 kilograms, and the speed that it moves at is 5 meters per second. Kinetic energy is energy of motion. The greater the speed, the greater the kinetic energy. We use the equation kinetic energy equals 1/2 mv squared to find the amount of kinetic energy. Mass is 5 kilograms. And velocity is 5 meters squared. And velocity, 5 meters per second, and velocity is squared. The first thing that we need to do is square our velocity. Before we can multiply it by anything, we need to square the velocity. That's the first step. Squaring the velocity means multiplying the velocity value by itself. When we write that out, we see that 5 times 5 is 25. Then we have 25 times 5, and then that will be multiplied times 1/2. Well, 5 times 25 is 125. And then we can do the last step, 1/2 times 125, or 125 divided by 2. And we get 62.5. Every quantity in science needs a unit except a count. So what is the unit? Energy is measured in the unit joules. So our answer is 62.5 joules. That's how we solve and calculate the quantity of kinetic energy this ball has. And here are the steps written out a bit more neatly for you. Try it out and see what you get for your answer. Did it match the answer we just arrived at? Make sure you can do the squaring of the velocity and the multiplying of the additional parameters. All right, let's try another problem. Let's try calculating potential energy. It says a 4-kilogram ball sits at the top of the stairs. What is the potential energy of the ball at the height of 6 meters? So we have some stairs, and we have a ball at the top of those stairs. The higher the object is, the more potential energy it has. If it has the potential to fall off the shelf, off the table, off the stairs, it has potential energy. If it has height above the ground, it has potential energy. Let's set up this problem and see what potential energy that ball has. potential energy equals M is mass. Mass, that's 4 kilograms. This ball is 4 kilograms in mass. Times G. You're not going to find a G in the question. Remember, G is a constant, and we always plug in 9.8 meters per second squared. And then times H, and our height is 6 meters. Let's multiply 6 times 9.8 first. When we multiply 6 times 9.8, we get 58.8. Then we'll multiply 58.8 times 4, and we get 235.2. This is potential energy. Every value, quantity in science needs a unit except a count. What unit is potential energy measured in? Energy is measured in the unit joules. So you must add that unit after. And our ball at the top of a stairs at the height of 6 meters has potential energy of 235 joules if it's a 4 kilogram ball. And here are the steps written out a little bit more neatly. What did you get? Did you get the same answer we just calculated? Good for you. That is